Hi everyone, welcome back to Code Silica. This is day 11 of our 150 days of LeetCode interview question series. Today's problem is container with most water, a very popular two-pointer interview problem. Let us go through the problem statement first. You are given an array where each value represents the height of a vertical line. You need to choose two lines such that they form a container holding the maximum amount of water. For example, for the array having elements 1, 8, 6, 2, 5, 4, 8, 3, 7, the maximum water that can be stored is 49. So initially thinking is like the water held depends on the minimum height of the two lines and the distance between them. So the brute force approach is to check all possible pairs. This results in order of n square time, which is too slow for interviews. So the key insight here is moving the taller line will never increase the area. To possibly get more water, we must move the shorter line. So our optimized approach would be like this. We use two pointers, one at the start and one at the end. At each step, we calculate area and move the smaller height pointer. Why this works? Because each pointer moves at most once per index. We examine all meaningful containers in linear time. Let us walk through the same example once again. The maximum area formed between the height is 8 and 7. So the distance is 7. The area is 7 multiplied by 7 equals 49. Now let us switch to Java code and implement the optimized solution. Now let us move to the Java code and understand how the two-pointer approach helps us container with most water efficiently. We are given an array where each element represents the height of a vertical line. Our goal is to choose two lines such that they form a container that can hold the maximum amount of water. We must solve this in order of n time. So first we have the pointer initialization. We initialize two pointers. The left pointer starts at the beginning of the array and the right pointer starts at the end. These two pointers represent the two vertical lines forming the container. Now we have to track the maximum area. We use max area variable to keep track of the maximum area we have seen so far. Now in the main while loop, this loop runs as long as the left pointer is before the right pointer and each operation evaluates one possible container. Next, we have to calculate the container height. The water level of the container is determined by the shorter of the two lines. Even if one line is taller, water is spill over the shorter line. That's why we take the minimum height. Next, we have to calculate the width. The width of the container is the distance between the two pointer. The farther apart the lines are, the more water the container can potentially hold. Next, we have to calculate the area. The area of the water held is calculated using the formula area equal to minimum height into distance between the lines. Next, we have to update the max area. We compare the current area with the maximum area seen so far and update it if needed. Next, we have to move the correct pointer. This is the most important step. If the left line is shorter, moving the right line will not help because the height is still limited by the shorter left line. So we move the pointer that points to the shorter height in the hope of finding a taller line that can increase the area. Let us go through the example once again. Here we have a height array having element 1, 8, 6, 2, 5, 4, 8, 3 and 7. The maximum area is formed in between heights 8 and 7. Width is 7, so the maximum height is 7, so the area is 49. At last, after evaluating all valid containers, we return the maximum area found so far. Let's execute this solution. Now let's quickly jump to the time and space complexity of this problem. The time complexity is order of n because each pointer move only forward. Space complexity is order of n because we are not using any extra data structure. Here are some interview related tips. This solution uses the two pointer technique and always avoids brute force approach. Always moves the shorter pointer, achieves optimal time and space complexity. By using two pointers and always moving the shorter line, we efficiently find the container that holds the maximum amount of water. Here two pointer pattern is extremely common. Mention the area formula clearly and always explain why the shorter pointer moves. That's it for day 11. Tomorrow we will solve trapping rainwater. Subscribe to Code Silica for daily LeetCode interview questions.